Hi everybody, this is Simone from eloquentarduino.com, and in this video I'll show you the exact steps you need to train and deploy an Edge Impulse FOMO model on your ESP32 camera. We'll be following an extract from my ESP32 S3 camera mastery course, and you can find a link to the free version in the description. There are 12 steps to follow, but don't be scared, many of them are very short. First one is collecting images from the camera, so load the example sketch from the Eloquent ESP32 CAM library and upload it to your board. I will be using a Freenove S3 camera for this tutorial, but you can use any camera you already have. Be sure to set the correct configuration for your board and set the debug level to info. Now click upload and wait a few seconds. When the upload is done, open the serial monitor and you will find a few debug messages. For the moment, we are only interested in the IP address of the camera. So let's open. Okay, copy the IP address of the board into a web browser to confirm that everything is working fine. You will see the live stream of the camera. Let's see. Okay, a bit laggish, but that's okay. Okay, this is the object we are going to recognize. Now, go back to the tutorial. Okay, just be sure you have your setup ready. Then we are going to collect a few background images. So point the camera to the background and click Start Collecting. You will see a few images on the screen. So move the camera around a bit to collect different angles. Click Stop when you are done and delete a few redundant images. We don't need all of them. So, okay, these are our images. So click Download and enter background as a label. When you are done, you can clear the screen. And we are going to repeat these steps for the object that we want to recognize. We are going to collect 15-20 images for this first tutorial. You can always collect more images later if you need. So again, click Stop, check that the images looks good. Okay, download. And if you have more images to classify, repeat this step for all of them. Since we are going to classify only this penguin class, we can extract the zip file folders that we have on our disk. Now we are going to use the Edge Impulse platform to create a model. It's easy and free to use, so create a new project and add existing data. Check Select a folder and locate the background folder on your computer. Follow the checks as in my video, so automatically split between training and test, and enter the label background. Click Upload. Okay, and check Yes when prompted. Now follow these exact steps as they are written in my book. So go to Labeling Queue and just click Save Labels for each image. Since these are background images, we don't have anything to label. Now we are going to repeat this step for the object that we want to classify. So again, upload the data from your computer. Select the folder. Okay. Leave again automatically split between training and testing and click Upload. Go to Labeling Queue and now you have to draw the bounding box around the object of interest. Give it a label. And repeat this step for each image. Most of the times the bounding box will be tracked correctly across frames. Repeat this step for each class that you want to recognize. Now we are going to create and train a TinyML model in Edge Impulse. I'll show you every step, but it is really easy to use. So go to Impulse Design on the left, enter the image size, and add the blocks as I do in the video. I chose 48 by 48 sides because the model will run faster this way. Now move to Image on the left, set Grayscale mode, and click Save Parameters. Generate features and wait until it completes. It will take a couple minutes. When it's done, you will see a chart. Okay, go to Object Detection, enter the settings that I'm using in the video, and choose a different model that is FOMO 0.1. This is the one that runs smoothly on our boards. Click Start Training and wait until it completes. It will take 4 or 5 minutes. When the confusion matrix appears, check that the accuracy is good enough for you. We get 100%, so it's okay. To get an estimate of how long it will take to run on your board, select Expressive ESP from the device menu. On S3 board, the model will run faster than this, actually. Now, the last step on Edge Impulse is to export the model as an Arduino library. So go to Deployment on the left, click Arduino library, and press the Build button. Be sure to leave selected the EON compiler and quantize the model. This will generate a zip file that we need to import in the Arduino IDE. So, last step is to deploy this model on our board. We are going to create a new blank sketch in the Arduino IDE. Let's call it FOMO tutorial. The name really doesn't matter. Okay. Then we will import the zip file that we downloaded from Edge Impulse. So go to the sketch, include library and add zip library. Locate the file on your computer. Okay. Then we will copy paste the provided code. It is included in the book that you can download from the description. It will run FOMO at every frame and print the detection result. Be sure to replace the correct name of the zip file you downloaded and set the camera model you are using. I'm using a Freenove S3 board. So let's upload this. It will take a long time the first time you upload. It took 5 minutes on my computer to upload, but that's normal. So when it is done, open the serial monitor and you can see the classification results. You can read that it takes 40 milliseconds to run on my board. So this is a live demo of me taking pictures of the penguin, and you can see the classification results on the right with the coordinates and the score of the classification. And this is it for this video. I show you the exact steps to train and deploy a FOMO model on your ESP32 camera. So don't forget to download the free book from the description and follow all the chapters. If you want to support me, you could buy the paid version of the book with more chapters and more advanced projects.